One of the things that I think is really interesting about chemistry and thinking about limiting reactants is how it used to be understood. Today, when you take your typical general chemistry class, you know the balanced chemical equation, you know your starting material, and you can figure it out. What's fascinating is to really think about, well, how do we know what the balanced chemical reaction is? And that gets to some experimental methods that people used in the past that we don't necessarily need to use today. To exemplify this, what we have in front of us are 4 unknown powders. And what's interesting about these 4 unknown powders is they're actually all the same things. So in each of these is some mix of copper chloride and sodium phosphate. And right now, with the copper chloride and sodium phosphate in differing amounts, there's some extent of surface reaction that's happened from the molecules bumping against each other. But for the most part, in their solid state, the reactions don't really proceed because the molecules aren't really interacting with each other that well. The thing that's different between each of these is the amount of copper chloride versus sodium phosphate. And what we can look at is what happens when we take these solids, we mix them with water. Water will act to initiate or speed up the reaction that can occur because looking at your solubility rules, this is copper 2 chloride and sodium phosphate. Both are soluble in water. So by putting these in water, we're going to allow the copper ions, the copper plus 2 ions, to find the phosphate ions, and we should make a copper phosphate precipitate. What we want to look for as we do this are a couple things. One, we want to look for the physical changes that occur. So we'll start with this unknown. It's this nice bright blue powder. And we're just going to, if we were doing this in a more experimental method, we'd be a lot more careful about how much we put in. But we're just going to put some into a beaker. And then we're going to add water. And one of the things we really want to look for is we do want to look for any physical changes that occur just from adding water. Now, as the 2 salts, the copper chloride and the sodium phosphate, dissolve in the water, we should actually form a new precipitate at the same time. I'm going to go ahead and put this one onto the stir plate and let it stir around for a moment. And to do that, we've got this nice magnetic stir bar. We put that in there, put it about in the middle, and we let it stir. I accidentally picked a plate that's somewhat temperamental, but we'll just let that stir. This will speed up the rate at which the copper and the phosphate find each other to form that precipitate. And what we're going to be curious about is once that precipitate forms, what's left in solution? Are there copper ions left in solution, or are there phosphate ions left in solution? Or neither? Because we have those 3 possibilities. There's the possibility that we were learning last week, in which both the copper and the phosphate are at the equal molar ratio, where they have the right number of moles to perfectly react, and we've got nothing but sodium chloride salt water left over. There's the possibility that there was more copper chloride than sodium phosphate, with the mole ratio in mind, in which case we'll have copper ions left in solution. Or there's the possibility that there is excess sodium phosphate, more sodium phosphate than we need, and we'll have sodium phosphate ions left in solution. While we're letting that stir, let's go ahead and look at some of our other unknowns. And if I remember correctly, I think this one is interesting. So this one is a nice green solid, which is interesting to me first off because this really blue solid and this really green solid are actually made from the same constituents, right? They are the same materials, but just in different ratios. We're going to go ahead and put that green material in there. Probably somewhere between, probably just over a gram. We're going to add water to it, just like we did before. And this one, when we add water, the amount of water doesn't really matter here. The water is just there to make it so that the copper ions and the phosphate ions can find each other. But this solution has a dramatic color change, right? It goes from that greenish color and becomes this really blue color. We're going to have to get that on the stir plate as well. And here we have our first solution made from the blue powder, and we end up with blue powder. So it seems kind of boring. But really, what we want to find out is, well, what's left in solution? So we're going to have to do a separation. And to do that, we're going to use this funnel and flask setup. With a piece of filter paper. So I'm just going to take this filter paper, fold it once, fold it twice. I'm essentially making a little funnel. So that way we can catch the solid. Right? If we want to analyze the liquid, we want to get the liquid away from the solid, so we're not analyzing the solid as well. I'm just going to, again, the amount of water doesn't matter, so I'm going to use a little water to wet that down. And we're going to take this blue solution, I'm going to go ahead and pour that in. Now, this filtration process is not that exciting, so I'll probably speed this up in the video. I am trying to get all of this solid out as well, because we could theoretically get a % yield and figure out how much solid we made from the mass if I measured everything. So we can already see one noticeable difference between these two solutions. Right, we've started with the same materials, copper chloride and sodium phosphate. We put them through the same process, add water, stir, filter, and we're collecting on top essentially the same blue powder of copper phosphate. But the solution on bottom is quite different. And that difference really depends on how much of each material was there at the start. What we're collecting is the excess solution left over. So down here we have two ions that we're definitely going to have, and one other possibility. So the sodium and the chloride are definitely going to be down there. Those are both spectator ions in our net ionic equation. So there's definitely sodium and chloride in the bottoms of both of these flasks. Then it's a question of phosphate or copper, or neither, right? Those last two, the ones that are participating in the reaction, could be in excess or could not be in excess. And what we're going to do is we're going to test that liquid to see what is excess. I'm going to go ahead and I'm going to do this next powder while we're waiting for those two to filter, just for fun, because why not? This one is a nice, this one actually looks really different from the other ones we've done so far. It's a nice green chalky powder, and with just a little bit of water, it takes on this really vibrant green color. But as we add more water so that the reaction can happen more, we switch over to that copper phosphate blue precipitate. And maybe we'll be able to make a determination from the color beforehand in terms of what's excess and what's limiting. That's part of why I'm curious about doing these other two samples. The last one is this blue kind of chunky powder. Looks very similar to our first sample. There are chunks of white in this one, which I haven't seen in any of the other samples, but you can see inside there. Maybe you can't see very well, but there's a few white chunks. And we're going to go ahead and add our water. We'll put these both on the stir plate and see if we get anything interesting out of them. Okay, so we're going to go ahead and test our excess solutions. Now I can actually already tell which thing is excess and which thing is limiting just from the color. And here's a pretty good indicator. So this is a copper chloride solution. So copper ions in solution take on a blue color. Here is a sodium phosphate solution. Sodium phosphate ions in solution, sodium ions and phosphate ions in solution don't take on any color. So just from that, looking at this blue solution, I have a hunch that there's copper ions left over. And in this one, I have a hunch that copper ions are not left over. What we're going to do to test that is we're going to transfer some of the blue solution to a test tube, and we're going to see if we can make a precipitate form from the liquid by adding other material. So if I add more copper chloride to this, we don't get any noticeable change. And that is because there's already copper chloride ions in solution. Right? So adding more copper chloride to a solution that has copper chloride, you're not doing anything. But if we instead add sodium phosphate to our excess solution, we very quickly get a precipitate forming. So that means in this test tube, there were copper ions and not phosphate ions. So our first sample, our second sample, the one that was green at first and formed a blue precipitate, had excess copper chloride and limiting sodium phosphate. We can do the same type of analysis with our other solution. So, first thing I'm going to do, I'm just going to jump to the one that I think is going to be interesting. And to the solution, I'm going to add copper ions. I think because of the color, mostly because of the color, I think that there is excess sodium phosphate. Now there's the possibility that there's nothing as well. So, So when I add that, okay, no, there is a precipitate forming. It was hard for me to tell at first. But you can see from that cloudiness that there's definitely a precipitate forming. So there was phosphate in solution that precipitated with the extra copper I added. So in our first sample, the one that was blue and had the clear liquid afterwards, we can figure out that that solid powder we had had copper chloride as the limiting reactant because I needed to add more to make the reaction happen. For our second sample, the one that was this kind of dark green, there was sodium phosphate limiting because I had to add extra sodium phosphate in order to make more reaction happen. Here, after letting it sit for a little bit, you can see there's definitely a precipitate settling to the ground, to the bottom of the test tube. Now, I got a little curious, and I want to see what the liquid looks like off of our last two samples. So I'm going to start, the one that I'm really curious about is, do the green powders, there were two green powders, do they both have copper chloride in excess, making it so that their wash solutions are blue? Even with the first drops being collected, it's really clear, or really obvious, that the solution is not clear, it's blue. So it turns out that physical observation used to be how we figured out what the limiting reactant was. It took multiple steps of reaction filtration and then testing what was excess in order to figure out the correct ratio for reactions. So you could imagine sometime in the past doing this for dozens and dozens of combinations of copper chloride and sodium phosphate to find the correct ratio of those two in order to make a reaction happen. And it was literally decades of people doing chemistry that led to our current understanding of charge balance, finding the right compounds in the reaction, and the ratios of reactants to make products through this relatively simple experimental process, where instead of doing it for 3 or 4 samples, you just do it for dozens.